Had we not finished problem number 4? Had we done part of this here? Okay. So just to give you a heads up, we hadn't finished the second part, but we had done part A. So I want to make sure that everybody's comfortable how to do this on your calculator. So guys, remember, on my calculator, the first thing I'm going to hit is I'm going to hit my second button, and then I'm going to hit the button that says vars, okay? So if you take a look-see here, I'm going to grab my calculator right here, turn it on, okay, clear that out. Okay, so guys, I'm going to go second, and then the vars button, okay? And I'm going to look for one that says binomial PDF. So I'm going to start scrolling down here, and that one right there, okay? So binomial PDF. And, okay, so guys, when I do that, let me write it over here. So when I get my binomial PDF, the first thing it's going to ask me for is my n. And let's see, so I can grab my handout real quick. So I can show you. Okay, so the first thing is going to be the number of trials. The second thing is going to be our probability. And then our next thing here will be our x, right? So guys, if I was to sort of start doing this problem out, number one, what was our n in this case? How many people were we going to start selecting? 6, right? Because it tells right here n is 6, okay? P is the probability. What's the probability that these people are going to think that Congress should help write standards for school food? What is the P number? 0.34, because how many people agree we should do this? 34%, right? Okay. And then guys, my X number, if you notice here, the X number takes numbers from 0 all the way to what? All the way to 6, right? So X is going to be 0, 1, all the way to the number 6, right? So when I grab my calculator, right, and I have that binomial PDF, we already said that our n number was 6, right? And then I'm going to do a comma. We said our P number was point what? 34, okay? And then guys, essentially what I'm going to do, I'm going to do this a certain number of times. So I'm going to put 0 the first time, okay? And then I'm going to close it off. Oops, I didn't want to do that. Second, vars. There we go. So we said 6, comma, 0.34, comma, we said 0, and then let me close off my parentheses, and I'll hit enter. And so that first number that we came up with should have been something like 0.08. Guys, if I go again to 4 decimal places, would I put 26 or 27? 27, right? So 0.0827. Okay. And then if I'm going to do this all over again, remember, I don't have to type in the whole thing. I can go second and what? Enter, right? Entry. And then I can come back and just change that 0 to what number now? To a 1. Okay. And guys, again, if I go to 4 decimal places, would I put 2 or 0.2555 or 2.554? 555. Okay, so 0.2555. Are we making sense on how to use the calculator? Yes. Okay, so is your screen a little different? From the last, yeah, I think it was from the last problem. Okay, so look, if your screen is slightly different, let's do this. So look, again, first thing I'm going to do, clear that out. I'm going to go second vars, right? I'm going to come down until I find binomial PDF. Okay, I'm going to enter that in. Does your screen look more like this one? Okay, so number of trials, that's just my n. What do we say our n value was? Okay, so let me clear that out. Let me put the number 6, okay? My P, what was our P number? 0.34, okay? And then the first time, didn't we put what number for X? 0, okay? Guys, all I'm going to do now, hit enter. Do you see how it comes out just like the way the other one was? Okay, then I can enter it in, right? What did I do wrong? So second vars. There we go. We said 6, 34, 0. Okay, enter. Okay, there it is. Okay, so do y'all come up with that number? Okay, and then guys, remember, so if your calculator looks like this, now at this stage, you can just do the same thing. Hit second entry, and then all you're gonna do is change that 0 to a what? To a 1. Right? And then I'm gonna keep playing this game until I go from the 1 all the way to what number? All the way to 6. Marisol, I know the other day you were saying you were having trouble with the calculator. Is it making it a little bit better today? We're doing better? Anybody else have any questions, guys? I want to make sure that we're good with this part here. Okay? All right, so guys, would y'all do me a favor? If we come back to our screen, does anybody have any of the other numbers filled out?
We had it, but we couldn't. This would be an issue, right, with the decimal place. So like on this problem.
Man, you're obsessed with those decimals, right?
I am, just because I got shocked. So we're using, you just assume you use 3 points in something like
I'm going, I just said, let's go 4. I just said, let's go 4, right? Again, Fred, when you're doing the homework, it's going to be very specific. It's going to tell you how many to write, right? Right now, just for the sake of argument, I'm saying, let's go 4, right? But I could have said, hey, I could have said, let's go 1, but I never want to go 1 because I'm cutting off so many other numbers if I just go with 1, right? Guys, did anybody come up with any of the other numbers yet? Okay, so what numbers did we get? I'm sorry. And we went by 3s. Okay, so I'll tell you what, let's be consistent with what we did the other night. Let's go with 3s. Okay? All right, I know, but look, we did the other nights, we went 3s. Let's keep it with 3s. That's okay. What did we get up for number 2? I don't remember what we got. Okay, 0.83 then? Okay, so let's do that. Let's do this. I'll tell you what. Come back. 0.083. What about the second one? 0.255. Okay. What about number 2? 329. Okay. 226. 087. 018. And then one more? 002. Okay. All right, so now we came up with those numbers. Now, let me see. If I scroll down here, guys, a little bit further. Whoa. Okay. So, number 1, just to give you a heads up, there's your binomial PDF. And then, guys, those of you who, like Fred and Jordan, those of you who have newer calculators, I want you to look right here. Isn't it doing it the same way yours is? Right? So, guys, if your calculator is a little bit newer, it's going to look like these here. And if your calculator is a little bit older, this is what it says. Binomial PDF, remember the first thing is the number of trials, then your probability, then your x, right? Okay, it says identify any values of the random variable x. So it's asking me, look for values of x that might be considered unusual. That just means that the probability is less than 0.05. Okay, so let me ask you a question here. If you look at these numbers here, are any of those numbers smaller than 0.05? Any other ones besides 6? 5 and 6, right? Aren't these numbers here smaller than 0.05? Right? Because look, guys, if I were to go to say 2 decimal places, wouldn't that be 0.02? And that would be 0.00, right? If I was going to 2 numbers, I'm looking for 0.05. So the 2 numbers for x would be at 5 and what? 5 and 6, because their probabilities are smaller than 0.05. Does that make sense? Okay. All righty. Let's see what else we got here. So I'm going to keep kind of scrolling on here and going to the next part. Okay. So, guys, I'm trying to give you sort of a hint on what you're going to do here when you're using your calculator. But let's take a look at this problem. It says the survey found that 34% of U.S. adults have hidden purchases from their spouses. You randomly select 200 adults with spouses. What's the probability that exactly 68 of them have hidden purchases from their spouses? Okie dokie. All right. Okay, let me ask you a question. How many people did we ask? 200. There's my n. Okay. What's the probability that they have a hidden purchase from their spouse? 0.34. Okay, guys, what is my x number going to be in this case? There's only one other number in the problem. 68, because we're trying to figure out what's the probability that exactly 68 of those 200 people have a hidden purchase from their spouse, okay? So guys, what are we gonna use again? The binomial PDF. What is my number of trials? 200. What's my probability? 0.34. What's my X number gonna be? 68, right? So again, I'll turn this thing on, clear it out, second vars, come down here, binomial PDF. I'm going to put 200, comma, 200, comma, 0.34, comma, 0.68, close it off. Or not 0.68, but 68, thank you. Thank you. There we go, 68. Hit enter, and the probability I'm coming up with. So again, guys, let's go to 4 decimal places, since that's what we've been doing. 0.059, 0.0595, right? 0.595. Okay. Alrighty. Okay, so guys, now if I look at the next problem, it says. Refer to problem number 4. It says 34% of voters think that Congress should help write standards for school food. You randomly select 6 voters and ask them whether Congress should help write standards. The random variable X represents the number of voters that think Congress should help write standards. Okay, so it says find the probability that exactly 3 voters think that Congress should help. Okay, so let's take a look here. We're going to come back and do this problem. What was our N in this case? How many people are we going to ask? We're going to ask 6 of them, right? Okay. What's the probability that they think that Congress should intervene? 0.34, okay. And guys, for part A, what is my random variable X going to be? X is going to be 3, right? Okay. So I'm going to come back to my calculator. I'm just going to do second entry, and I'm just going to fix my numbers back here, right? So delete. Okay. In this case, we said our our number was 6. Our probability was 0.34. And then we're looking for exactly how many voters? 3. And put enter. Okay, so here's my answer. Guys, if I were to round that to 4 decimal places, 0.2259 or 0.2260? 0.2260, right? Okay, so we're coming up with, for a probability of 3, that's the same thing, right? Yeah, I mean, if you give me $5 or you give me $5 and no pennies, you still gave me $5, ¿verdad? Yeah, okay. Now, guys, look at part B. Find the probability that at least 3 voters think Congress should help. What does that mean? What does it mean, at least 3? So let's think about it this way, at least 3. That means that the smallest number we want to get is what? The smallest number we want to get is 3, right? Could we get 4? Think about what the word at least 3 means. 4 we could get, right? Anything above 3. At least 3 means 3 should be your lowest number, right? So guys, aren't I going to do the same thing? I'm going to say, look, I want to find the probability of 3. But I want to find also the probability of what? Okay, where are we going to stop at? We're going to stop at 6 because we're only asking how many people? We're only asking 6 people. Okay, so we already know what the probability of 3 was. We said that number was 0.2260. Okay, now let's do the same thing, but let's do the probability for 4 of them, right? Guys, wouldn't I just go second entry and then just change that 3 to a what? To a 4. Enter. 0.0873. Okay. 0.0873. Okay. And then we're going to do that all over again, but we're going to change that 4 now to a 5. Okay. Second entry. Come back over here. Let's change this guy to a 5. Hit enter. 0.0178. Okay. 0.0178. And one more time, and we're going to change that 5. Oh, 80, I'm sorry. Oops. Eraser. No huss, guys. All right, and then we're gonna do this one more time. That's gonna come out in the video too. And we're gonna change that 5 now to a 6 and 0.0015. Okay. So 0.0015, and then we're gonna take those numbers and we're gonna add them all up. Okay, so let's take a look here. So if I add them all up, 0.2260 plus 0.0873 plus 0.0180 plus 0.0015. Are you getting 0.3328? Okay. So, that much. So when we added them all up, we came up with 0.3328, right? Okay. Now, I want us to look at part C. Part C says, find the probability that fewer than 3 votes think Congress should help. What is fewer than 3? Well, let me ask you a question. Is 3 fewer than 3? No. So it would be what number or less? 0, 1, or 2. Okay, so guys, before we go on and say, look, let's do this again and put 0 and then go back and do 1 and then go back and do 2. Remember the other day when we were talking about probabilities and I said, suppose I told you that the chance that it's going to rain tomorrow was 60%. What chance would it not rain? 40. How did you get that? You said 1 minus, or 100 minus 60 gave us 40, right? Guys, if we already know what the probability is for 3 or more, then we can find the probability for less than 3 by saying, let's take 1 minus, there you go, 0.3328. We could do, let's do our Binompdf for 0, for 1, and 2, and add them up. But if we already know what it is for 3 or more, the way we could find less than 3 would say, let's take 1 minus that answer. Whatever is remaining, that's right. So we take 1 minus 0.3328. Are you coming up with 0.6672? There you go. And that right there saves me a little bit of time in the sense that I don't have to go through the Binompdf as many times anymore, right? Okay. All right, so guys, I know there's another problem here, and then there's still a couple more, right? Let me make sure where he is. All right, so let me grab this part here. So this one here, guys, is just using a table. So let's see if we can figure out how to do this using our table. Let me see if I can. Trying to figure out how to enlarge this a little bit, but I can't see it right now. But anywho, look what it says. About 55% of small businesses in the United States have a website. You randomly select 10 small businesses. What's the probability that exactly 4 of them have a website? Okay, so what's my N number in this case? 10, okay. We're looking for a probability of how many of them have the website? 4, right? 4 have the website. What's my probability though? 0.55. Guys, I want to show you what we can do here. If you look here on this table, it gives me values like here's N is 2, N is 3. Here N is what number? N is 10, right? Okay, and that's what it tells me that my N is 10, so that number is going to be right here. We're going to go to, if our probability is 55, so I'm going to look for P equals 0.55. If you notice, guys, here's my 0.55 sort of column, right? And then we want exactly how many of them? 4. So I'm going to go right here. Here's my 4. Okay. So wouldn't it be that number right there? Which one would be 4 and 55? 0.160, right? And that's just using a table. So guys, when you're doing your homework, sometimes a table will pop up or it'll allow you to use a table. That's how you would do it using a table. Okay. Some people like the chart better, so. Yeah. I'm sorry? Instead of having to use the calculator? I don't know. I just couldn't tell you is if every single problem is going to have that table, right? Because then we have to look at a lot of different n values, and like I don't know if they're going to remember the one we did earlier where we were asking the people that were married, how many of them had what? How many of them had secret purchases? N was what number? Do you remember how many people they asked? 200, right? Yeah, so that table would get real big real fast, right? All right. So guys, let's finish up the notes here for 4.2, and then I'll give you some time to work on homework, and then we'll do one last section of 4.3. All right, so look at the next problem here. We have a couple of formulas. So here's my mean, here's my variance, here's my standard deviation formula, okay? So guys, remember, the one thing I want to mention is that mu stands for the mean, right, or the average, okay? So let's take a look here. It says, in San Francisco, about 44% of the days are clear. Find the mean, variance, and standard deviation for the number of clear days during the month of May, and interpret results and determine any unusual events. Okay, so let's take a look. Number one. Anybody know how many days there are in May? 31. Okay. All right, so guys, right here we're going to put 31. Okay. P, the probability that we're going to have clear days would be what number? 0.44. Okay. So guys, what percent of the days would not be clear? Anybody know? So if 0.4, so think about it this way, yeah, 56, right? Okay. All right, so guys, we're going to find a couple of things. We're going to find, it says, let's find the mean, the variance, and the standard deviation. Okay, so let's first find the mean. Look at the formula. The mean just says, let's take n times p. So let's take 31 times 0.44. So if you take your calculator, 31 times 0.44, are you coming up with 13.64? Right? Okay. Now, let's find our variance. So guys, look, the variance is the sigma squared, right? The little O with a hat being squared. But look at the formula. What numbers am I going to multiply? All of them, right? N, P, and Q. So I'm going to take 31 times 0.44 times 0.56. And are you coming up with 7.6384? Okay. And then guys, look at the next part, standard deviation. Standard deviation says, what are we going to do with the number that we just found? We're going to take the square root of it. So the square root of 7.6384. So let me take the square root of that number. And guys, are you coming up with something like 2.763, maybe 8, if I round to 4 decimal places? Something about that? Yeah? What do we do? Look at the formula, Red. The formula says whatever number you got right here, what are you going to do to find the standard deviation? Take the square root of it, right? So all I did is take the square root of that number. Does that make sense? So far we're good? Good, good. Okay. So guys, there's just a little bit more here left in 4.2. I think it's just these next two problems, or next two parts of it, and then we'll be done. We'll take a little break, and we'll come back and do 4.3. So look what it says here. It says refer back to problem number 5. So just to make sure we all understand what problem number 5 was, let me come back. Problem number 5 was this one right here, right? This was the one that said 34% of U.S. adults have hidden purchases from their spouse. How many people were we selecting? 200. Okay, so what I'm going to do is I'm going to come back over here, And I want to see if we can figure this out. So number one, we said that our n in this case was 200. And what was our probability again? 0.34. Okay. So let me ask you a question. What do you think less than 68 of them means? Let me ask you a question. If we took 200 people and we asked them, how many of you 200 people have a hidden purchase from your husband or wife, and none of them said, I don't have any hidden purchases from my, that would be what number? Would that be less than 68? Okay, so we're going to find the probability of 0, and then we're also going to find the probability out of all those 200 people. Suppose one of them said, yeah, I have hidden purchases from my husband or wife. That would be what number? 1. And we're going to keep playing this game, guys, all the way until we get to what number? 68? 67, right? Because the question says less than what? Less than 68. Now, guys, we could go through Binompdf, put in n is 200, p is 34, 0, and then write down that number. And then second entry, do it again, and 1, right? And we could change, we could keep doing that, but we would have to go all the way to what number? Okay, we'd be here for a long time. So there is another feature on your calculator, and I want you to notice what this one is called. It's called binomial what? What is that letter right there? CDF, okay? So guys, what I'm gonna do here is I'm gonna turn on my calculator, right? I'm gonna clear that out. I'm gonna come back. How do I get to the binomial area? Anybody remember? So second VARs, right? We're gonna go here. We're gonna scroll down until we find the one that says binomial CDF. Notice it's the one right under PDF, right? Okay. So I'm going to go like this. My n, the number of trials was still what? 200, okay. Our probability was still, wasn't it 34? 0.34, right? Guys, what we're going to do here, we're going to stop at 67 because the CDF means cumulative. Cumulative means we're going to go 0 and 1 and 2 and 3, and we're going to start adding up all those numbers together all the way till we get to the number 67. So I'm going to stop at 67, okay, and I'll hit enter, and there's our answer. So I'm coming up with, if I go again, guys, if I go to 4 decimal places, would you agree 0.4734? Okay, so 0.47, oops, let me, 0.4734, okay. And guys, if your calculator is a little bit newer, right, then what I'm going to do here, I'm going to clear this out. I'm going to go second VARs. I'm going to scroll down until I find binomial what? Binomial CDF, right? I'm going to enter that in. So my number of trials is still going to be 200, okay. My probability is still going to be 0.34. My x value is going to be the number 67 because we wanted less than 68. So remember, CDF, guys, means cumulative. Means I'm going to go from 0 to 1 to 2 all the way up till I get to the number 67. Hit enter again, and probably one more time. And there's our answer, right? So that's everybody from nobody says I have hidden purchases, all the way up to 67 people. Cumulative. Remember what cumulative means? It means you're accumulating, you're adding more and more and more and more. So we're adding the probability of 0 plus the probability of 1 all the way till we get to the number 67. Okay? Right? Okay. Now, guys, if we already know what the probability that less than 68 of them, if we already know what the probability of less than 68 of them have hidden purchases, what's the probability that 68 or more? How would I do that? We would subtract. We would say, let's take 1 minus 0.4734. And if you take your calculator and you say, what is 1 minus 0.4734? Are you coming up with something like okay. So according to this data here, 68 or more of the 200 couples have hidden purchases from the husband or the wife. Right? Escandalosos. All right. So guys.